Hi, this video we're going to be talking about different types of circuits, series and parallel. Well, remember the old Christmas lights? If one light bulb in that string is broken, the entire string not gonna light up. So that's those light bulbs are connected in series. For example, right here, you have 220 and 470 and 1000 ohms. They are connecting in a sequential order, so electrons flow in sequence through this resistor. However, in parallel, those three resistors, they divide electrons, it's going to divide its path. For example, if this is I, there's going to be, I call this mother string, and then they're going to go to this tributary I1, there's another branch I2 and I3. And so basically this I has branched up to those three currents, right? However, in this situation, for series, the current going through the resistor 1 and the resistor 2 and the resistor 3, they are all equal. Okay, so that's the difference so far. And also, you're going to see the combination of series and parallel. For example, 1000 ohms and 10 ohms, they're going to have different current, I1 and I2. But then, however, this 220 and this 470, they are going to have the same current, right? Same current going through. And the same current going to branch off to this I, come over here, this commodity stream, right, is gonna branch up to I1 and I2 because that's the characteristic for parallel. The current is gonna split off to different branches in parallel series. And now another thing, so we know about the series and the parallel and the combination of them. We know the current, how that's gonna be different. For current, I'm going to make a note. For current, is going to be the same for series, right? However, how about the voltage? The voltage here, if I call V1, the voltage across 220, and the voltage across this 470, and the voltage across this 3000, they are not equal. They are going to, voltage drop, going to depend on, you can use that, you can solve it using Ohm's law. Okay, so for example, I have V1 here is going to be equal to this I, and here, since the current is same, I'm going to get rid of subscript, just say all equal to I times 220, right? And this V2, Ohm's law, same current going through the series, the ohms is 470. Then you can do the same thing for V3. V3 is going to be the same I, current, going through series times the ohms R, which is 1000. And however, for series, the voltage drop across those different resistors, if you add them together, they're going to equal the total voltage across the circuit. So total voltage is 5 volts. So I'm going to write down this 5 volts is equal to sum of all those voltage add together. So that's the characteristic for series. Okay, so voltage added up equal to the total voltage across the circuit. And each voltage, we used Ohm's law here. Now let's look at parallel. We said that the current is going to be split off to different circuits. And how about voltage? Here they have the same node. So the voltage, V1 at 220, V2 across 470 ohms, V3 across 1000 ohms. They all are equal. So V1 is equal to V2 equal to V3. So I'm just going to say equal to volt. get rid of subscript V. And if you want to figure out the I1, we can use Ohm's law. It's going to be this voltage divided by 220. And I2 is going to be the same voltage because they are in parallel series, divided by 470. And I3 is going to be same voltage divided by 1000 ohms, right? Okay. All right, so that's characteristic of series and parallel. A quick recap: if it's connecting in series, all the current going through of them is going to be the same. And then, however, for parallel, the voltage across those parallel components are the same. Then for series, if you want to figure out the voltage, you can use Ohm's law for each component. You add them together. The sum of it is going to be the voltage across the entire circuit. And then same thing for parallel. The current, sum it up, is going to be equal to the total current. So that's it. But now I'm going to focus on resistance now. We talk about voltage, we talk about current. Now we're going to think about the equivalent resistance. So for example, here you have series, you have 3 different resistors, 220, 470, and 1000. They are connected in series, as you can see. What do you think the total resistance is going to be? It's if you had a multimeter and you have the correct resistor, you can go ahead and do this experiment, and it's added together. That's going to be the equivalence. So Req is going to be sum of all those individual resistance, or you can written as sigma from 1 to n and Ri. So for this situation, our total equivalence is going to be 220 plus 470 plus 1000. Right, so that's going to be 1690 ohms. All right, so how about you have the same resistor? This time they are connected by parallel. As you can see, if you have a breadboard and you connected them in the same node as right here, then what's going to be the resistor then? And you measure, you're going to get around 130. And how that comes from is using this mathematics equation here. Equivalent is going to be reciprocal of 1. It's 1 over sum of all those reciprocal. So for this problem will be 1 over 220, 1 over 470 plus 1 over 1000. You add them together, then use 1 over that. So I suggest you to pause to calculate, so make sure you verify this number. All right, so that's equivalent for both series and parallel. We know the equation for both of them. Now let's look at an example now. So consider the circuit. So 3 volts across 2 ohms and 6 ohms. So this is in parallel. What is the total current supplied to the resistor? So they're asking this current, the mother current, I. How much power is consumed by the resistors together? All right, so how do we go ahead and solve this one? Since it's in parallel, we're going to find the equivalent, right? Equivalent is going to be 1 over 2 ohms plus 1 over 6 ohms. For this problem, there are just 2. Let's pause, see what you have. So you have 1.50 ohms here, because this is 3, 6, add together, it's 4, 6, right? So it's 2 over 3, and a flip, it's 3 over 2. So it's 1.5 ohms. And a quick thing here, when you're finding out equivalence for parallel, the number is always this number should always less than R1 and also always less than R2. If your value ends up to be greater than even the minimum resistance here, which is 2 here, right? Then you know you need to go check your calculation. They likely have something not correct. Okay, so when you have this resistance as 1.5 ohms, and remember they want us to find a current, and so what you just find out is this is cluster. If you combine these two together, what is the resistance? It's 1.5 ohms. And then we're going to use Ohm's law. Ohm's law, V is equal to IR. We want to find this current. So this current is going to be the total voltage across this total equivalence resistance. So it'll be 3 volts divided by 1.2 ohms. That will give us 2 amps. That's going to be the total current to the resistor. So you solve the first problem. Then the power equation, there are 3 expressions, V times I. Do we have both? Yes, if we do, we can just use this one. Or remember, quick review, you can use I squared R or V squared over R. Here, we can use either one of the 3. I'm going to just use V times I. Our V is total of 3 volts. The total current going through is 2, right? So that's going to give us 6. And the power unit is going to be in watt. So that's going to be the answer for that problem. All right. So that's a good example to combine all the concepts, parallel, series, and Ohm's law together. Now let's look at this problem. They want to find equivalence for this given current. This is a combo, right? Have a combination of both parallel, 100, 100, and in series. So here illustrate the different steps. If this is R1, R2, R3, R4. First step, you combine all the resistor that's connected in series. So 50 and 150. Those two add together, 200. So that's going to be our 200. Then the second step, we're going to consider R3 and R4 combined using parallel resistance. So it's 1 over 1 over 100, 1 over 100. Down to is 50, right? And so that's equal to 50. And R12 you got earlier, it's from 200. Now you're going to combine those two together. They are connected in series, aren't they? So when you add them together, 200 plus 50, then you got the total equivalence, which is 250. That's your answer for this problem. All right, so hopefully that will give you some idea about to solve a circuit that has combination of both series and parallel. Again, a review on how current is doing for both series and the parallel, and how voltage is doing on both of them. All right, that's all for this one. See you next time. Bye.